evening to everyone. We are going to start. We have already started. You have already started. Circular motion, right? So, just a quick revision. Uh, if a particle is moving along a circle and the particle is here, then we define the radial axis and we define the tangential axis. So this is the tangential axis and this is the radial axis, and the fact that this particle is moving along a circle with some speed v. I'm saying speed because the direction of the velocity keeps on changing. So since the speed of the particle is constant, I'm assuming that it is constant for now, which is the definition of uniform circular motion. If the speed changes with time, then it is non-uniform circular motion. So for the moment, I'm just talking about uniform circular motion. So if the speed of the particle is v, then the acceleration of the particle must be equal to v square by r, and the direction of the acceleration must be towards the center of the circle. Right? ये पढ़ा है ना? ये this is all been covered. Yes, no, yes. Okay, good. Okay, so we can also describe circular motion in terms of angular variables. Right? We can also describe circular motion in terms of angular variables. And why do we need angular variables, by the way, for circular motion? Anybody? Why do we need angular variables for circular motion? I just want to ask a couple of quick questions, then we'll move on. First question: why do we need angular variables? Why not just use the linear variables of distance, displacement, velocity, speed, acceleration? बताओ भाई, anyone? Unmute होना है किसी को? Anybody wants to tell me? Well, angle is changing, तो उससे क्या हुआ? My question is, why do we need angular variables? Why do we need angular variables? Why do we need angular variables? हमें एंगुलर वेरिएबल्स क्यों चाहिए? हाँ भाई, path is continuous नहीं. Okay, so I will tell you. I will tell you. Reason is actually more obvious than you can think. So supposing that I have a disk. Okay, I'm talking about a disk. I'm not talking about a ring. Well, I am talking. I can talk about a ring also. So for this, if this disk is rotating with a angular velocity, in this fashion, and I look at three particles on the disk: the red guy, the green guy, and the blue guy. Then after some time, the red guy will be here, and the green particle will be here, and the blue particle will be here, right? So initially they were along this line, and now they are along this line. So the displacements of these three particles, I can draw very easily, remembering that displacement is a vector drawn from the initial position to the final position. So the displacement of the three particles would be something like this. And the distance traveled by the three particles would be something like this. Right? Now, for these three particles, can you tell me what will be the relationship between the average velocities of the particles 1, 2, and 3? Remember that average velocity is defined as displacement of over time, right? So what can you tell me about the velocities, average velocities of particles 1, 2, and 3? Well, the average velocities of particles 1, 2, and 3 are all going to be different, right? And yes, exactly, Shiva. Very good. So, yes, Aryan. So, V3 will be greater than V2 will be greater than V1. Right. So, despite the fact that the three particles are on the same object, right? Despite the fact that the three particles are on the same object, the three particles have completely different uh, velocities, average velocities, right? The instantaneous velocities of all the three particles will be same. The speed of the three particles will be different. Sorry, instantaneous velocity will be different. The speed of the three particles will be different. Whether you find out average speed or whether you find out instantaneous speed, everything will be different. And therefore, of course, the acceleration of each and every particle is going to be different. And I know that this disk is made up of an infinite number of particles, right? Out of which I have only considered three for explanation purpose. So if all these infinite particles have a different velocity, different displacement, different acceleration, then it is going to be very difficult to talk about the motion of the disk, because I am going to tell you about infinite number of velocities, infinite number of displacements, infinite number of acceleration. However, although all these things for these particles are different, there is one thing which is common, and that is the angular displacement. Right? So theta is same for all the particles, and therefore the angular velocity is the same for all the particles, right? And therefore the angular acceleration will be same for all the particles. So if I were to take linear motion variables as the explanation, or if I were to use linear motion variables to describe the motion of this disk, then things will get very, very complicated very, very suddenly. And therefore we need angular variables for a shorter description of motion, right? Which will convey the same information to me without going into an infinite set of information. If, however, there is only one particle that you are dealing with, which you are actually, because we are dealing with particle mechanics at the moment and not multiple particles, single particle mechanics at the moment. So since we are dealing with only one particle moving along a circle, you can take either the angular variables or the linear variables to describe the motion of that particle. Okay? It will not matter. Uh, it will not, have a drastic effect, a drastic difference on the description, right? Okay. So this is so later on since we are going to deal with disks, cylinders, we are going to deal with spheres, we are going to deal with hollow spheres, solid spheres, we are going to deal with cones. So it is better that we introduce you to angular variables at this moment. But when we come back to rigid body dynamics, we will revise quickly angular variables once again. Okay? Okay. So what are angular variables? Quickly, the angular variables that we know of. So there is a domain. I can construct a table. Huh. I can construct a table where I can talk about the linear or the translational variables, and I can talk about the angular or the rotational variables. And it turns out that there is a one-to-one correspondence between linear and angular variables. So if you have here displacement, then you have here angular displacement, right? Now, the units of angular displacement is radian. Remember that the dimension of the angular displacement is null. There is no dimension. And is it a vector quantity or a scalar quantity? Is it a vector quantity or a scalar quantity? बताओ भाई प्रतीक्षा क्या बोल रही थी? एग्जैक्ट 50-50 स्प्लिट है आंसर्स में. हाँ, गुड शिवेन, यस. So I think I think Pratiksha and Shiven, they are correct. Small angular displacements are vector quantities and large angular displacements are scalar quantities. Okay? Why is this? Why is this correct? What does it mean? Well, it is very difficult for me at this stage to tell you about why this is so. Okay? Uh, when in class 12 you have studied matrices, okay, determinants and matrices is a chapter that you will be doing in class 12 maths. When you have done that chapter and you are still interested in knowing the proof of why angular displacement is considered to be a scalar when its value is large and it is a vector when its value is small. I will give you a mathematical proof. Okay, but right now I'll give you something else. Okay, I'll give you another explanation. When we were dealing with scalars and vectors, I told you that scalars and vectors are actually a type of something, a mathematical object called a tensor. Okay, if you remember, right? So there is something called a scalar quantity. There is something called a vector quantity, and both of these things are really a type of tensor quantities, right? So scalar quantity is a tensor quantity of, ये सब मैं अभी मिटा दूंगा, rank 0, and it has one component. Okay, a vector quantity is a tensor of rank 1 and it has 3 components, right? उसके बाद के quantities का कोई नाम नहीं होता है, but a tensor of rank 2 will have 9 components, and a tensor of rank n will have 3 raised to the power n components. So what is a tensor? मतलब क्या है वर्ड, ये मैथमेटिकल मतलब ही क्या है वर्ड? तो वेक्टर का क्या मतलब? वेक्टर का मतलब ये है that we are dealing with a set of mathematical objects which follow certain predefined rules, right? So we have two vectors. वो वेक्टर्स को लिखना कैसे है वो रूल है, वो वेक्टर्स को ऐड कैसे करना है वो रूल है, वेक्टर्स को सबट्रैक्ट कैसे करना है, वेक्टर्स को मल्टीप्लाई कैसे करना है, ये इसका रूल है, राइट? एंड ए वेक्टर कैन बी completely defined by 3 components along 3 axes which are mutually perpendicular to each other. So such a quantity is called vector. In the same way, a tensor, which is a superset of vectors and scalars, is a mathematical object which has certain predefined rules and regulations. How will you add tensors? How will you subtract tensors? In fact, actually, there is no rule of addition and subtraction. There is only one rule, and that is how tensors transform when viewed from one axis to another, right? So if I tell you that the temperature of my room right now is 25 degrees Celsius, and you are to view this room, or you can take a measurement in this room that I am in from anywhere, okay? Will it change? Will the temperature change? Or will the reading of the temperature change depending on your point of view? Will it always be 25 irrespective from, irrespective of आप उल्टा मुंह करके देख रहे हो या उल्टा सर करके देख रहे हो या टेढ़ा सर करके देख रहे हो या पीठ किया हुआ है मेरे कमरे की तरफ या मुंह किया हुआ है मेरे कमरे की तरफ? Will it always be 25 or will it be different for different observers? The temperature is the temperature. It will be always the same for different observers, right? Therefore, temperature is a scalar object. Okay, so a tensor of rank 0 has a rule, and the rule is that the tensor of rank 0 does not change when coordinate axes are changed, right? That is the टेंसर ऑफ रैंक 0 का रूल, अगर कोई ऐसा ऑब्जेक्ट है जो कि चेंज ऑफ कोऑर्डिनेट से चेंज नहीं हो रहा है, वो टेंसर ऑफ रैंक 0 है या स्केलर। अगर मैं एक वेक्टर की बात करूं और मैं वेक्टर को एक दूसरे कोऑर्डिनेट सिस्टम से देखूं, राइट, इफ यू रिमेम्बर बहुत पहले मैंने एक क्वेश्चन दिया था, ये वेक्टर है और इसका कंपोनेंट निकालना है इस एक्सिस के अबाउट, और फिर इसका कंपोनेंट निकालना है इस एक्सिस के अबाउट, राइट, चेंज हो गया था, कंपोनेंट्स चेंज हो गए। तो अगर कोई ऐसा ऑब्जेक्ट है जिसके कंपोनेंट्स डिफरेंट एक्सिस में डिफरेंट हो जाते हैं according to a certain rule, we had actually worked out the rule, if you remember. I don't think most of you will remember, but हमने एक एक्चुअली रूल वर्कआउट किया था कि अगर ये एंगल थीटा से मैं टर्न कर दूंगा एक्सिस, तो कोऑर्डिनेट्स कैसे चेंज हो जाएंगे, cos थीटा sin थीटा पे डिपेंडेंट कोई एक क्वांटिटी आती है। So such a quantity which follows this rule of change of transformation is called a tensor of rank 1. Right? So similarly, we have tensor of rank 2, and I've actually used the wrong word here. Component मुझे नहीं use करना चाहिए. It is actually 9 separate quantities, 9 separate numbers which will define this tensor of rank 2, which does not have a name actually. So this theta, this angular displacement, is actually a tensor of rank 2. In fact, we will find later on that a lot of quantities which I will write down here as a vector, maybe as a scalar, will have or will be a tensor of rank 2, which, since it is not in our syllabus and we don't want to study, 9 coordinate axis नहीं होंगी, नहीं 9 coordinate axis नहीं होंगी, 3 coordinate axis होंगी, लेकिन वो ऐसे होएगा, x axis, फिर x y x z, उसके बाद से आएगा y x y, ओके, उसके बाद से y z, उसके बाद से आएगा z x, उसके बाद से आएगा z y, उसके बाद से आएगा z। ये 9 ऑब्जेक्ट्स होंगे। अब ये इसका मतलब क्या है, प्लीज लेट्स नॉट गो इनटू दैट। इसका मतलब ये है कि इस क्वांटिटी को x एक्सिस के अबाउट मेजर किया, इसको x इक्वल टू y के अबाउट मेजर किया, इसको x इक्वल टू z के अबाउट मेजर किया, इसको x इक्वल टू माइनस y के अबाउट मेजर किया, y के अबाउट मेजर किया। तो ये 9 क्वांटिटीज, 9 कोऑर्डिनेट एक्सिस नहीं, 9 क्वांटिटीज है, इसीलिए मैंने बोला, मैंने कंपोनेंट वर्ड गलत यूज किया था। So these 9 quantities, how are they measured? What are these quantities? इससे हमें कोई मतलब नहीं है at the moment. But the angular velocity is actually a tensor of rank 2. Right, now, since we are not going to be dealing with tensors at all, tensors of rank 2 at all, therefore I need to simplify this. Okay, I need to simplify this in a more palatable way. I need to tell you कि हाँ भाई ये देखो ऐसा है। तो सबसे palatable way जिससे हम आपको we can tell you is that angular velocity, angular displacement is a tensor of rank 2. Don't want to say this. We will say that when its value is large, it will behave like a scalar, and when its value is small, it will behave like a vector quantity, right? Like I said, it is in your syllabus. I can prove this, but once you have studied matrices and determinants thoroughly, then we can come back. If you are still interested, I can prove that small angular displacements will be vectors and large angular displacement will be can be treated as scalars. Okay? So we will treat angular displacement. Okay? We will treat angular displacement as a vector. because we are not going to be dealing with large angular displacements. Even if we are dealing with large angular displacements, it will only be about one axis, so you are very safe considering that as a vector as well. Okay? तो अगर मैंने बोला कि मैंने एक डिस्क को 2 पाई रेडियन से घुमाया, और नहीं प्रतीक्षा, लेस का मतलब होता है डी थीटा. डी थीटा इज ए वेक्टर, राइट? एंड ऑफ कोर्स the question should be there in your mind कि अगर d थीटा वेक्टर है तो थीटा क्यों नहीं वेक्टर है, क्योंकि d थीटा को ऐड करते जाएंगे तो अल्टीमेटली हमें थीटा मिल जाएगा. तो ऐसा कैसे हो सकता है कि वेक्टर्स को ऐड करते जा रहे हैं और हमको स्केलर मिल गया बीच में कहीं से, राइट? So that is a genuine question. The answer to this genuine question is that in reality it is neither a vector nor a scalar but something else entirely, which we can approximate as a vector when it is small, and we can approximate as a scalar when it is large. But like I said, when it is large also, then you can also treat it as a vector quantity. अगर एक डिस्क को मैंने 4 पाई रेडियन से क्लॉकवाइज घुमाया और मैंने उसको पाई रेडियन से एंटी क्लॉकवाइज घुमा दिया, राइट, तो टोटल एंगुलर डिस्प्लेसमेंट डिस्क का क्या हुआ? अगर मैंने एक डिस्क को 4 पाई रेडियंस क्लॉकवाइज घुमाया और फिर पाई रेडियंस एंटी क्लॉकवाइज घुमा दिया, तो उसका टोटल एंगुलर डिस्प्लेसमेंट क्या होएगा? उसका टोटल एंगुलर डिस्प्लेसमेंट क्या होएगा? 4 पाई क्लॉकवाइज घुमाया, 4 पाई रेडियंस. आपके सामने ही अगर कोई गोल सी चीज रखी है, 4 पाई मतलब 2 चक्कर होता है, पाई मतलब आधा चक्कर होता है, तो 4 पाई चक्कर मतलब 2 चक्कर आपने क्लॉकवाइज घुमाया और आधा चक्कर एंटी क्लॉकवाइज घुमाया, तो आपने टोटल कितना घुमाया, राइट? दैट इज द क्वेश्चन. माइनस पाई अपॉन पाई क्या बोल रहा है? It is 3 pi clockwise, right? It's very easy. So what have you done? This is vector addition. You have done 4 pi minus pi, right? So please don't worry about what angular displacement is. For all practical purposes, for us it is a vector quantity, right? हाँ, कोई specific question आ गया एग्जाम में कि नहीं अब आप बताओ एंगुलर डिस्प्लेसमेंट क्या होता है, और उसमें ऑप्शन दिया हुआ है कि व्हेन इट इज लार्ज इट इज स्केलर, small it is vector, so you can take that option, right? Okay, so next up we have velocity, right? And the corresponding quantity is angular velocity. The units are radians per second. The dimension would be per second, and this is definitely a vector quantity. Why can I say that this is definitely a vector quantity? Well, it turns out that any relationship which is followed by linear variables is followed exactly by angular variables as well. Because ultimately, linear variables are a description of motion. Angular variables are also a description of motion. So if v is equal to, or the definition of v is dx by dt, then the definition of omega must be equal to d theta by dt, and we know that d theta is definitely a vector quantity, and therefore omega is therefore omega must be a vector quantity, right? Question number 3. What is the direction of omega? What is the direction of omega? नहीं, एंगल का डायमेंशन नल होता है प्रतीक्षा. एंगल का कोई डायमेंशन नहीं होता. What is the direction of omega? What is the direction of omega? बताओ भाई हैं? हाँ, लेकिन पार्थ ये तो एम्बिग्यूअस आंसर हो गया ना, इसमें तो दो पॉसिबिलिटीज आ गई ना. Parth has answered along the axis of rotation, and my counter point is that along the axis of rotation has two possibilities, right? एक डिस्क रोटेट कर रही है, एक डिस्क रोटेट कर रही है, तो उसका एक्सिस ऑफ रोटेशन ये है. अप भी हो सकता है, डाउन भी हो सकता है. गुड, यस, हाँ, वेरी गुड. So you will find the direction of omega using the right hand rule, right hand thumb rule. The fingers of your right hand will curl. Okay? Fingers of your right hand will curl along a diagram of the Bangyat banana. Fingers of your right hand will curl along omega. Okay, and the thumb will give you the direction of the angular velocity vector, right? Again, what is going to happen is that throughout our syllabus, you will find that we will not be dealing with two-dimensional omega, right? Very rarely will we be talking about two-dimensional omega. And ये चैप्टर में तो डिस्कस ही नहीं करना है. जब हम रिजिड बॉडी डायनामिक्स खत्म कर देंगे, एंड में I will show you how to deal with two-dimensional omega. So for us, omega will always remain one-dimensional. And if you remember from our study of motion, linear motion, कि अगर कोई भी चीज one-dimensional होती है, तो उसको प्लस और माइनस से हम उसका डायरेक्शन बता सकते हैं, right? So that is what we are going to do with omega as well. Next quantity is acceleration, a, right? And we know that a के corresponding होता है angular acceleration. Angular acceleration would be radians per second square. The dimension would be s raised to the power minus 2, and this is definitely a vector quantity. And just like a is equal to dv by dt, alpha is equal to d omega by dt. This is also equal to d2x by dt square. This is equal to d2 theta by dt square. This is equal to v dv by dx, remember. So this is equal to omega d theta by d omega. So it will be omega d omega by d theta. And whatever relation is followed by the linear variables is followed by the angular variables. For example, यहाँ पे if acceleration is equal to 0, then we have velocity is equal to displacement upon time, or displacement is equal to velocity into time. Here, if alpha is equal to 0, then we definitely have omega is equal to theta upon t, okay? Or we have theta is equal to omega t. If acceleration is equal to constant and is equal to a naught, then we have v is equal to u plus a naught t, and s is equal to ut plus half a naught t square, and so on and so on. Here also, if alpha is equal to constant is equal to alpha naught, then the final omega is equal to initial omega plus alpha t, and I don't know, theta is equal to omega initial t plus half alpha naught t square, so on and so on. Whatever is the relationship followed by the linear variables is followed exactly by the angular variables, right? Okay. And so here I would like to give you one question, couple of questions really. Question number one: a potter's wheel of radius, I don't know, 1.1 meters is rotating at 30 radians per second, and after 5 seconds it stops. Find alpha, the find angular displacement, find distance, and displacement of particle stuck to the rim of the wheel. Okay, try this. Should be able to do this. We already covered. हाँ भाई, you work it out. I'll give you 2 more minutes. Okay, I'll just come back. क्या हो भाई? कोई नहीं, nobody. ऐसा ना करो. दीक्षा, तुलिका, आर्थ, खुशी, सब लोग सो गए लग रहा है. मैं भी सो जाता हूँ. सारे आंसर दो. 2 आंसर थोड़े चाहिए मेरे को. ये जो आंसर दिए हैं वो सही है. पार्थ एंड दीक्षा. यस. आर्यन, तेरा पहला आंसर गलत लग रहा है मेरे को. हाँ सही. सारे आंसर चाहिए मुझे. चिंदी नहीं चाहिए. 2-2 आंसर. I have asked you 1, 2, 3, 4 questions. Four answers. नहीं, सही तो है. गलत कहाँ? दोनों सही है. बाकी दो तो दो आंसर. I will write question 2 here only, I think. डिस्प्लेसमेंट 0 है, श्योर मैं तो नहीं मालूम. Hi. So for the people who are not able to do this, this is not very difficult. You can always convert the problem into a linear problem and then do it. Okay. So a wheel, we forget about the wheel, we forget about the radius, is rotating, is moving at 30 meters per second. ये मैं केवल अपने मन में बोल रहा हूँ. And after 5 seconds it stops. Find acceleration, find displacement. Okay, so omega initial or u is given by 30 radian per second, and time after it stops is given by 5 seconds. Final omega, it has stopped, it is given by, therefore it is given by 0. And we need to find alpha, right? We need to find alpha. So to find alpha, what I do is final omega is equal to initial omega plus alpha t is 0 is equal to 30 plus alpha into 5. So alpha is equal to minus 6 radian per second square. Theta also we need to find is omega I plus omega f by 2 into t. Remember, s is equal to u plus v by 2 into t. Right? ये उसका angular counterpart है. Omega initial is 30 plus final is 0 divided by 2 into t. This is equal to 15 into 5, that is 75 radians. Right? And at some point, of course, you will have to sort of travel between the linear and the rotational parts, right? And to do that, we have a very simple relationship between these variables. And here we have x is equal to r theta. This is just the definition of angle is equal to arc upon radius, nothing else, nothing complicated. And if you differentiate this, you get v is equal to r omega and a is equal to r alpha. By the way, before I go back to solve more problems. यहाँ पे बाद में आने वाला है, मास यहाँ पे आने वाला है, फोर्स यहाँ पे आने वाला है, मोमेंटम यहाँ पे आने वाला है, काइनेटिक एनर्जी, और ये सबके कॉरेस्पॉन्डिंग कुछ ना कुछ रोटेशनल ऑब्जेक्ट्स, रोटेशनल डोमेन के वेरिएबल्स रहेंगे, right? And we'll discuss them later. For the moment, it is only these three. Okay, so let's get back here. So I want to find the distance traveled of a particle stuck to the rim of the wheel. This is not very difficult. So for the C part, x is equal to r theta is equal to 1.1 into 75. This is equal to कितना बताया था मेरे को, कितना बताया था, हाँ वेरी हार्ड है ना, 82.5। अच्छा, अब मेरे को जो सबसे इसमें जो सवाल है, जो गड़बड़ वाला है, वो डिस्प्लेसमेंट, राइट? Actually, it is not very difficult. If this, supposing, is the initial location of the particle, then where is the final location of the particle? Well, we know that 75 radians ये move किया है, right? Approximate answer ही निकालेंगे हम। तो 75 divided by 2 pi कितना होता है? पहले तो ये निकालते हैं। 75 divided by 2 pi कितना होता है? तो भाई कोई तो बताओ, मैं कैलकुलेटर नहीं निकालूंगा। 75 divided by 2 pi कितना होता है? 75 divided by 2 pi कितना होता है? क्या भाई, कोई कैलकुलेटर नहीं रखा है क्या अपने सामने? 11.9, okay? 11.9. 75 divided by 2 pi is 11.9. इसका मतलब ये पार्टिकल 11 गोल चक्कर खाएगा। okay? अबे अलग अलग आंसर कहाँ से आ सकता? 117.8। ये क्या बताया सोना तूने? 2 पाई, पाई 3 होता है, 2 गुणे 3 6, 75 डिवाइडेड बाई 6, 117 आंसर कहाँ से आएगा? नहीं, 11 से 13 के बीच में आना चाहिए आंसर। 11.9। इसका मतलब ये हुआ, assuming that the answer is 11.9, okay, what am I doing? What am I doing here? I am doing 75 divided by 2 pi, approximately equal to 11.9 radians, right? Sorry, not radians. Radian nahi hai. This means that this represents the number of full circles, or at least 2 pi radians हो गया ना ये 11 बार 2 पाई रेडियन तो करेगा ही करेगा ना, तो इसका मतलब ये फुल सर्कल हो गया 11 बार, और 0.9 टाइम्स फुल सर्कल, इसका मतलब 0.9 इंटू 2 पाई, 0.9 इंटू 2 पाई का मतलब हुआ 1.18 पाई, नहीं 1.8 पाई, 1.8 पाई। इसका मतलब ये हुआ that if I were to measure the angle as it goes round and round, 2 pi, 4 pi, 6 pi, करते 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 11 टाइम्स मैं करूंगा, पार्टिकल यहीं आया। अब इसके बाद से ये 0.9 पाई, 0.9 इंटू 2 पाई और घूमेगा। 0.9 इंटू 2 पाई का मतलब हुआ 1.8 पाई, 1.8 पाई का मतलब यहाँ कहीं है। This will be the final. This will be 1.8 pi, and therefore this will be 0.2 pi. Okay, and therefore the displacement which is being asked will be this. It is simply a triangle having a isosceles triangle having 1.1 as two sides, 0.2 pi as the angle, and I'm asking you for the third side. What is the third side of an isosceles triangle of angle theta? याद है मैंने आपको ये बताया था that you should remember this. This is to be remembered because I will use it again and again and again in vectors. Very good, प्रतीक्षा. लेकिन थोड़ा सा गलत है ना, थोड़ा सा गलत है. हाँ, it should be twice of sine theta by 2r sine theta by 2. Yes, yes, yes. Good. Good, guys. Very good. Yes, yes. So this is how we make the connections. 2r sine theta by 2. This is the length of this side. And this will be equal to 2 into r, which is 1.1, into sine of theta by 2, which will be 0.1 pi, which I'm not going to calculate. This is only the magnitude of displacement, right? If I was really pedantic about it, I would ask you the direction of displacement as well, which should not be really a big problem. You can consider, you can always consider this point. You can always consider this point to be the origin, and you can draw a coordinate axis, and then I cap, j cap, and you can tell me what the displacement will be. Okay, or you can consider this point as the origin. Maybe this will be easier, and you can tell me what the displacement will be. Okay. आया ये सबको समझ में? Is this understood by everyone? Is this understood by everyone? How we use previous things and how we use new things. सबको आ रहा है समझ में? Okay, please solve the second question.
सर मैंने कैलकुलेटर में डाला, वो मेरे को 117.8 ही दिखा रहा है.
Yeah.
75/2 पाई मेरे को 117.8 ही दिखा रहा है.
कौन सा कहाँ डाल दिया तूने भाई?
सर गूगल में डाला मैंने.
गूगल में तूने डाला है? हाँ.
हाँ.
तूने
हाँ, सर,
गूगल
मैंने
में गलती निकाल दी. सुंदर
फोटो भी
पिचाई
खींचा
को फोन
सर,
लगा.
आपको भेजूं?
फोटो खींच ले उसका. फोटो खींच ले, स्क्रीनशॉट ले ले, छोड़ना मत.
सर भेजा आपको मैंने.
भेज भी दिया तूने? अच्छा.
हाँ.
तो सुंदर पिचाई को मेल करते हैं, इसको अटैच करके गूगल सही किया जाए. तू पाई है कि क्या है वो?
सर 2 पाई है वो.
आई डोंट नो क्या किया भैया इसमें.
सर अब लगता है मेल करना पड़ेगा.
मेल कर ही दे. हाँ, तो फिलहाल सेकंड क्वेश्चन कर, उसके बाद मेल करना. वेरी गुड अनीश, बहुत बढ़िया. Yes, Pratiksha, but yes. So if you remember, this is just a copy of another question which was there in linear mechanics that you have done before. ये बुकलेट में भी है और ये ट्यूटोरियल शीट में भी था और ये रूडोव में भी है और 10 सोर्स मिल जाएंगे इस क्वेश्चन के. The original question, of course, was that a particle moving with velocity v naught undergoes deceleration a is equal to minus k root v. Find the distance when it stops. So I've just converted it into a angular problem. Everything remains the same, only the symbols they change. Maths remains the same. बिल्कुल सही खुशी. यस. Yeah, so the way to do this, of course, हाँ बिल्कुल सही. Yes, yes, yes. So the way to do this is to just write alpha is equal to alpha is equal to omega d omega by d theta is equal to minus k root omega, and you can rewrite this equation as root omega d omega is equal to minus k d theta, and we integrate this from omega naught to 0, and this goes from 0 to theta, and upon integration you will get omega naught raised to the power 3 by 2 upon 3 by 2 is equal to k theta, right? So theta is equal to 2 omega naught 3 by 2 divided by 3 divided by 1 by multiplied by 1 by, right? Extremely simple calculus variable acceleration का problem, right? ठीक है, आगे बढ़ूं मैं, इसका स्क्रीनशॉट ले लीजिए, आगे बढ़ता हूं मैं. Okay, so how to deal with how to deal with circular motion, in mechanics. Okay. Mechanics में circular motion से कैसे deal करें? So I'm going to write down the steps, right? Again, this is just revision. I'm going to write down the steps. So the first step is that the instantaneous position of the particle is the origin. Yeah? इसका क्या मतलब हुआ? इसका मतलब ये हुआ, अगर पार्टिकल यहाँ है तो ये ओरिजिन है, पार्टिकल यहाँ है तो ये ओरिजिन है, यहाँ है तो ये ओरिजिन, यहाँ है तो ये ओरिजिन, राइट? ऐसा क्यों करते हैं ये भी मैं बताता हूँ. I'll tell you this in a moment. Second step is that you draw the radial, tangential, and the third axis from origin. Now I've written radial, tangential, and third axis. In reality, of course, you'll be able to draw only two. However, I will give you questions where all the three axes will be involved, and of course, in that question, you will not be able to solve. And then when I draw the forces along the three axes, then you will say, हाँ ये तो ऐसे होता है. Most of the questions, of course, only two axes will be drawn and forces will be along two axes only. So we draw the radial axis, we draw the tangential axis, tangential, this is the radial, okay, and the third axis I cannot draw on the diagram, it is perpendicular to your board, perpendicular to your screen, okay, that is the third axis. So I want to, before I move, I want to answer two questions, right? I don't know whether you have this in your mind or not. First is, what do we mean by circular motion in mechanics, right? And what am I writing down here? What are the steps I'm writing down here? Well, we have seen different kinds of motion, and the approach that we had up till now was actually very simple if you think about it. You simply draw a free body diagram, okay, and you draw an axis and you find the components of all the forces, and then you apply the second law. That's it. The complications, of course, are there. The complications arise if even after applying the second law, you are not getting an answer because the number of equations are less than the number of unknowns. If that happens, then there are two things you can do. Number one is you can make the constraint equations from the given problem, right? And one equation or two equations, however many equations are required, you can make the constraint equations. Of course, that makes the problem a little tougher. Or the second is you can look for pseudo forces. You can look for frames of reference in which the motion of one particle becomes easier to handle. And if that frame is a non-inertial frame, then you can make a free body diagram with respect to the non-inertial observer in which pseudo forces will be acting. Right? If you think about it, that is all that we have done. This single paragraph, this single small paragraph is the gist of all that we have learned in Newton's laws of motion over such a long period of time. So once again, you will draw the FBD in a given problem and you will write down F is equal to MA equations, and then you will find out either A or an unknown F, whatever is required. Okay. And if this is not sufficient to solve, then you will, of course, either make the constraint equations or you will look for some non-inertial frame of reference. We are doing exactly the same thing here, except for one thing. Okay? We are doing exactly the same thing here, and in fact, इसके बाद से जो steps आने वाले हैं वो वही होने वाले हैं. रेडियल एक्सिस बना दिया आपने, टेंजेंशियल एक्सिस बना दिया, थर्ड एक्सिस बना दिया. अब आप एफबीडी बनाओगे, कंपोनेंट्स निकालोगे, एफ इज इक्वल टू एम ए लगाओगे, राइट? So that the steps will remain the same. The second question that I want to answer is, why consider this radial and tangential axis? Why not take an axis at the center of the circle, right? Why not just take the standard XY axis? Well, you can, there is no problem, right? There is no problem. But I will later on, maybe in the next class, maybe in the next class, I will show you that there are other forms of coordinate axis apart from the Cartesian coordinate system. And I will show you why we don't teach these coordinate systems to you at this stage. Unfortunately, the line is a bit blurry. That means that uh, you are supposed to know the concepts of circular motion. You are supposed to apply it in a host of problems. One, for example, is the hydrogen atom, the electron in the hydrogen atom. So you are supposed to know circular motion, but you are not supposed to know the different coordinate axes, right? लेकिन केमिस्ट्री में आपको पढ़ाया गया होगा, केमिस्ट्री में जब एटॉमिक स्ट्रक्चर सर ने पढ़ाया तो आपको विनानी सर ने बताया होगा स्फेरिकल पोलर कोऑर्डिनेट सिस्टम के बारे में, राइट? I will not be teaching you spherical polar coordinate system, but I will be teaching you polar coordinate system, or at least some amount of polar coordinate system. And I will show you that why we don't prefer to teach you this at this stage. But it turns out, as I will show you, that handling circular motion in polar system, polar coordinate system, is much, much, much easier than handling circular motion in Cartesian coordinate systems. Especially when you are dealing with non-uniform circular motion, then Cartesian really becomes very, very lengthy, very, very cumbersome. And the polar coordinate system is actually formed, or the whole system is built around circular motion. So it makes handling circular motion very easy, right? So maybe in the next class, maybe in the next to next class, I will discuss it, I will show you. Because the polar coordinate system is easier to handle, right? Therefore, whatever I'm telling you here, steps 1 and 2, are really having their origins in polar coordinate system, right? So, because of the fact that you will choose the origin to be the instantaneous location of the particle, and because your axes will always comprise of the radial and the tangential axis, therefore your life will be very easy. If you choose to deviate from this path, then your life will be very difficult and miserable, because of the fact that in uniform circular motion, the acceleration of the particle is always radially towards the center, which is called the centripetal acceleration. Therefore, if you choose this coordinate axis, the acceleration will always be very well defined, and you don't have to find the components of acceleration. Okay? Even in the non-uniform circular motion, one component of acceleration will be towards the center, that is the centripetal acceleration, and the other component will be along the tangential acceleration, along the tangential axis. Okay, so third step. Third step is draw the FPD, find components, all forces. Fourth step, summation F radial, and this is always remembered towards the center, will be equal to M into A radial, but we know that A radial is equal to V square by R or omega square. Okay. Summation F tangential 0 for uniform circular motion, and summation F third axis is also equal to 0. And this is for all circular motion. Well, actually not all. अगर थर्ड एक्सिस पे फोर्स आ गया तो मोशन सर्कुलर नहीं रहेगा, क्या हो जाएगा? कैन एनीबडी टेल मी? अगर थर्ड एक्सिस पे फोर्स आ गई तो ये मोशन सर्कुलर नहीं रह जाएगा, ये मोशन क्या हो जाएगा? नहीं, नॉट स्फेरिकल, नो नो नो, नॉट इलिप्स, नो 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 नो। अगर थर्ड एक्सिस पे भी फोर्स आ गई, वेरी नाइस सॉन्ग, यस, एक्सीलेंट, यस। थोड़ा सा गलत वर्ड एक्चुअली यूज किया है, बट आई थिंक यू अंडरस्टैंड व्हाट आई एम टॉकिंग अबाउट. So the word to use is helical, okay, not spiral. Spiral motion तब आएगा. Can anybody tell me spiral motion कब आएगा? Can anybody tell me spiral motion कब आएगा? स्पाइरल मोशन तब आएगा जब इसका रेडियल डिस्टेंस चेंज होने लग जाएगा, राइट? इसका रेडियल डिस्टेंस चेंज होने लग जाएगा. But all this is beyond our syllabus. Okay, helical is not beyond our syllabus. We will be dealing with helical motion, but we will never be dealing with force along the third axis. Even if you get a force along the third axis, it is not really going to make much of a difference. जैसे हमने projectile motion में देखा था, the three axes are independent of each other. Here also the three axes will be independent of each other. Right? So if you do get a force along the third axis, circular motion as it is will continue, but now the particle will be coming out of your screen. Right? It will be helical. Helical motion का मतलब होता है ऐसा. सर्कुलर तो हो ही रहा है, बट साथ में ऐसे ऊपर भी चला जा रहा है. Helical motion. So this page is it. Okay, if you want to do any problem of uniform circular motion, all you have to do is come to this page, follow the steps. That's it. 4 steps. So let me give you a question. Tarun, third axis का नाम third axis. Literally, उसका नाम third axis. ये किया हुआ है क्वेश्चन ये. सबके पास HCV है ना? सबके पास है HCV? Anybody not having HCV? HCV खोलिए please open it because I don't remember the question. Solution नहीं देखना है किसी को, केवल question देखना है. So I think in this question they have a track like this and they have a bicycle traveling on the track. Please see the question. And they have said that this is 90 degrees, this is 90 degrees. देखिए question को. I think it's question 16, 17. I don't know. I don't remember. (22). Okay, delay. Okay. 22, page 115. HCV, page 115, question 22. Please do this. I think uniform. I hope uniform circular constant speed लिखा हुआ है ना उसमें. I think constant speed लिखा हुआ है. Please do this question. Answer पीछे दिया ही हुआ है. हाँ मास दिया हुआ है। आंसर दिया हुआ है ना, आंसर मेरे को थोड़े मालूम है। वाह हार्दिक वाह, एक्सरसाइज के एंड में देखो आंसर्स लिखा होगा, आंसर्स में क्वेश्चन नंबर 22 पे जाओ, आंसर दिया होगा। नहीं हो रहा है, जैसा मैंने बोला बिल्कुल वैसे ही करना है। अगर बाइसिकल यहाँ है, ये रेडियल एक्सिस हो जाएगी, टेंजेंशियल की हमें जरूरत नहीं है, और एम जी इधर होएगा, एन ऊपर होएगा, एम जी माइनस एन इज इक्वल टू एम बी स्क्वायर बाय आर। बाइसिकल यहाँ है, एन ऊपर है, एम जी नीचे, एन माइनस एम जी इक्वल टू एम बी स्क्वायर बाय आर। जब बाइसिकल यहाँ है और बाइसिकल यहाँ, एफबीडी तो सेम बनेगा, एम जी एन एन। लेकिन ऊपर वाले केस में दिस इज द रेडियल, दिस इज टुवर्ड्स द सेंटर ऑफ द सन, so you will get mg cos 45 minus n is equal to mv square by r, right? And of course mg sin 45 will be balancing the friction. In this case there will be a friction, but in the other wala case you will have n minus mg cos 45 is equal to mv square by r, and mg sin 45 will still be equal to friction. Okay. Sure, I will leave you here. Okay, do this question, try this question, get the answers, and we'll discuss this question in the next class. Meanwhile, please start with HCV now. If you have not yet started, which is should not be the case, we should be finishing HCV very, very rapidly. Next class में I will revise non-uniform circular motion if it has not already been done, and then I'll show you the polar coordinates में क्या होता है. And then finally we will discuss pseudo forces in rotating frames of reference. Okay. Non-uniform is not done. Okay, great. So ठीक है. So non-uniform I'll be teaching. Uniform circular motion के जितने भी questions हैं, please complete them from HCV. Right? And if you are not able to do, don't worry. Next class में we'll discuss some more questions of uniform circular motion, and then we'll move on to non-uniform. Chalo. I will stop here and we'll see you. नहीं, टेंजेंशियल और सेंट्रीपिटल में कोई रिलेशन नहीं है. टेंजेंशियल और सेंट्रीपिटल में कोई रिलेशन नहीं है. यूनिफॉर्म सर्कुलर मोशन में केवल इतना याद रखना है, ये जो मैंने अभी बताया. यूनिफॉर्म सर्कुलर मोशन में ये दिस, नॉन यूनिफॉर्म में ये चेंज हो जाएगा. Okay, chalo guys, bye. I'll see you in the next class.